Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullah. Dear students, today we are going to talk about chemical analysis. Chemical analysis is the topic of chapter 2. Chemical analysis is considered one of the most important branches of chemistry. Why? Chemical analysis plays an important role in the progress of many scientific fields, such as medical fields, agriculture fields, food and environmental industries, etc. So let's go started. First, what is meant by the chemical analysis? Okay. Chemical analysis is a branch of chemistry which study all the methods and the equipments which are used in the identification of the components and determine the concentration of each component in a substance or mixture, in a compound or mixture. Again, chemical analysis branch in chemistry concerned in explaining all the methods and the equipments which are used in the identification of the components and the concentration of each component in a mixture or in a compound. Importance of chemical analysis. Number one, what is the importance of chemical analysis in medical fields? In medical fields, we can use chemical analysis to estimate the concentration of sugar, albumin, uremia, cholesterol, etc. This helps doctor in diagnosis and treatment. Also, estimating the amount of the effective substance in medicine. Yes. Number two, what is the importance of chemical analysis in agriculture fields? In agriculture fields, we can use chemical analysis to know the properties of the soil as alkalinity, basicity, acidity of soil. Also, by using chemical analysis, we can determine the percent of all elements that present in the soil. Therefore, we can treat it. Therefore, the soil can be improved and treated by adding the suitable fertilizer. Number three, the importance of chemical analysis in the industrial fields. In the industrial fields, we can use chemical analysis to identify the products and the ores. Yes, for standard specifications. In the industrial fields, we can use chemical analysis to determine the identity of the products and ores for the standard specifications. Last, what is the importance of chemical analysis in the environmental fields? In the environmental fields, we can use chemical analysis to identify and measure all the harmful environmental pollutants in water, in air, in food. Yes, in air, we can determine the percent of carbon monoxide, sulfur oxides, nitrogen oxides, etc., and other air pollutants in air. Okay, let's move in. Kinds of chemical analysis. Chemical analysis, two branches, two kinds. Number one, qualitative analysis. See after me again, qualitative, from quality, qualitative analysis. Number two, quantitative analysis, quantitative analysis. Okay, first, what is meant by the qualitative analysis? Qualitative analysis is the type of analysis that aims to identify what? qualitative analysis, the type of analysis that aims to identify the components of a substance. Either this substance is compound or mixture. Again, qualitative analysis, the type of analysis that aims to identify, just identify the components of a substance, if it's pure, simple salt, or mixture. Quantitative analysis is the type of analysis that aims to measure, to determine the percent, the concentration of each component in the substance. Again, qualitative analysis, the type of analysis that aims to identify, make a line under identify, just identify the components of a substance, either it be compound or mixture. Quantitative analysis is the type of analysis that aims to measure, to what? To measure. Qualitative, to identify. Qualitative, identify the components. Quantitative, to measure the percent, to measure the concentration of each component. Okay. First, qualitative analysis. Qualitative analysis. In qualitative analysis, you should know that if the substance is pure, it can be identified by its physical constants, like a piece of gold, pure gold, piece of iron, yes, piece of copper. We can identify it by using the physical constants as melting point, boiling point, density, molar mass, etc. But if the substance is mixture, to identify its components first, we must separate their components. We must make a separation for each components, then identify them by chemical methods using the suitable reagents, as we know in this topic, as we know in the qualitative analysis. Qualitative analysis takes place in the form of series of selected suitable reactions performed. Why? To detect the kind of main components of a substance depending on the changes happened in these reactions. Again, our work concerned in this point. Qualitative analysis takes place in the form of series of selected suitable reactions performed. Why? To detect the kind of main components of the substance depending on the changes that happened in these reactions. You can put a question mark beside this point. This point is our work in this topic, as we know in the next session, inshallah. Qualitative analysis includes two branches. One, analysis of organic substance. This analysis will be studied in chapter 5, organic chemistry, inshallah. Number 2, analysis of inorganic substance. This topic, this point, our work today. Yes, our work in chapter 2. In this chapter, we will study just the analysis of inorganic substance. In this type of analysis, we will study how can we identify any inorganic salt, how to test for the ions. You can put a line under word ions. In this topic, you can know exactly how to test for the ions. The what? The ions that form the inorganic salt. Why ions and why salt? Okay. Any salt, as you know, any salt consists of, yes, basic radical. It's the positive ion of salt, which is named cation, and acidic radical. The acidic radical of the salt is the negative ion of the salt, which is named anion. Let's give an example. Okay. From your previous studies, you know that any salt is a substance derived from the reaction of alkali and acid. Alkali, you can say base plus acid give salt and water. You know that exactly. Let's give example. When we get sodium hydroxide, this substance is a base, and hydrochloric acid, a double substitution reaction takes place. The positive ion of base takes the negative ion of the acid, giving salt to consist of Ne cation beside Cl anion. And the negative ion of base takes the positive ion of acid, give water. Okay. Let's explain the sodium chloride salt as an example for any salt. Any salt like sodium chloride consists of two radicals. The left radical, which is the positive ion of salt, can be named basic radical. Why? Because this radical is cut from a base. Therefore, the positive ion of any salt, we can name it basic radical. The negative ion of any salt, the negative ion of any salt, we can name it acidic radical. Why? Because the negative ion of the salt is cut from acid. The positive ion of salt is named cation. The negative ion of the salt is named anion. Okay. Any salt consists of basic radical, positive ion, cation, and negative radical, acidic radical, anion. Okay. You should know that clearly any salt consists of positive ion and negative ion. Positive ion is named basic radical, the negative ion is named acidic radical. Okay. Therefore, to identify any salt, first we should test for its anion. First, we begin with testing for anions in our syllabus. Second, to test for its cation. If you have a salt in a jar, this salt, to identify it, first you should test for its anion. Second, you should test for its cation. Let's begin with testing for the anions of salts, the acidic radical of salts. Scientists classified the anions of salts into three groups. First, the group of the diluted hydrochloric acid. The anions group of diluted hydrochloric acid, you can name them. The first group of anions consists of 6 anions in our syllabus. What are the anions which can be detected by using diluted hydrochloric acid? Number 1, carbonates, CO3 minus 2. Bicarbonates, HCO3 minus 1. Sulfites, SO3 minus 2. Sulfides, S minus 2. Thiosulfate, SC2O3 minus 2. Nitrites, NO2 minus 1. The anions of diluted HCl, the anions which can be identified by using diluted hydrochloric acid. In our syllabus, 6 anions: carbonates, bicarbonates, sulfites, sulfides, thiosulfates, and nitrites. Nitrites, not nitrates. Nitrites, NO2. The second group, the group of the concentrated here, diluted hydrochloric acid, diluted sulfuric acid, concentrated. You know in the next sessions why I mentioned these two words, why the hydrochloric acid should be used diluted, why sulfuric acid should be concentrated, inshallah. The group of the conc sulfuric acid, chlorides, in our syllabus 4 anions: chlorides, Cl minus 1, bromides, Br minus 1, iodides, I minus 1, nitrates, not nitrite. Nitrite is the anions that can be detected by using diluted hydrochloric acid. Nitrate, NO3 minus 1, the anions that can be used, that can be detected by using conc sulfuric acid. Yes. The third group, the group of barium chloride. What are the anions that can be detected by using barium chloride? Phosphates and sulfates. You should ask yourself a question: why? Why these anions detected by diluted hydrochloric acid, but these anions detected by sulfuric acid, but these two anions detected by barium chloride? The rule used in this detection, the detection of anions is: the more stable acid can react with the salt of the less stable acid, giving the salt of the more stable acid and the less stable acid which decomposed, giving gases can be identified easily. Okay, why we use diluted hydrochloric acid to test for these anions? The answer is because hydrochloric acid is more stable than the anions, than the acids of these anions. Again, why HCl is the suitable reagent for testing for these anions: carbonates, bicarbonates, sulfite, sulfide, thiosulfate, nitrite. The answer is because hydrochloric acid is more stable than the acids of these anions. What is the acid of carbonate and bicarbonate? Carbonic acid. What is the acid of sulfite? And so we know all of these points clearly now in this session, inshallah. Why we use conc sulfuric acid? Why we use conc sulfuric acid is the suitable reagent to test for chlorides, bromides, iodides, nitrates. The answer is because sulfuric acid is more stable than the acids of these anions. Therefore, sulfuric acid can react with the salts of these anions replacing their acids. The acids of these anions are less stable than sulfuric acid. They can be given out in the form of gases, can be identified by using the suitable reagent. Why we use barium chloride to detect for phosphates and sulfates? The answer, because phosphates and sulfates are anions of higher stable acids. Phosphate is derived from phosphoric acid. Sulfate is derived from sulfuric acid, and these acids are high stable acids. Therefore, we use barium chloride because barium chloride salt in its aqueous form give BBT with phosphate different in its properties from the BBT resulted from sulfate. Okay, let's begin with the first group. The anions of diluted hydrochloric acid. The scientific idea. The scientific idea of the detection of the group of diluted hydrochloric acid. Why we use diluted hydrochloric acid? To test for carbonates, bicarbonates, sulfites, thiosulfates, and nitrites. Why? The answer, as we said before, because number one, hydrochloric acid is more stable than the acids of these anions. Hydrochloric acid is more stable than the what? The acids of these anions. What's meant by high stable acid? High stable acid has high boiling point. As the boiling point increased, stability of acid increased. Yes. Therefore, hydrochloric acid replaces the acids of these anions in the form of gases which can be identified with the suitable reagent. As we know in this session and the sessions in the next sessions, when you add hydrochloric acid to sodium carbonate salt, reaction takes place and the carbonic acid is given out, decomposed in the form of carbon dioxide gas, which can be detected by lime water. Okay, let's give an example. If you get sodium carbonate salt and add some diluted hydrochloric acid, the positive ion of the salt takes the negative ion of the acid, giving NaCl, sodium chloride. And the positive ion of the acid takes the negative ion of the salt, giving H beside CO3. CO3 carbonate valency 2. This is named carbonic acid. The carbonic acid less stable acid, so it decomposed into water and carbon dioxide. You should balance the equation. 2 Na, 1 Na, you should put 2 here. 2 Cl, you should put 2 here, yes. NaCl aqueous, H2O liquid, CO2 gas. What is happening in this reaction? In this reaction, we get salt of less stable acid and higher stable acid. Reaction takes place giving the salt of the higher stable acid and the less stable acid, which decomposed giving gas can be detected, can be identified easily by using glymometer. Okay. So the main idea, the main scientific idea that used in the detection of anions is, okay, stability of acid. If we get more stable acid, higher stable acid with the salt of less stable acid, okay, they produce the salt of the more stable acid plus the less stable acid. The less stable acid decomposed giving gas can be identified. The less stable acids, carbonic acid, sulfuric acid, hydrogen sulfide acid, H2SO3, HNO2. These acids, the acids of the 6 anions of the group of diluted hydrochloric acid. When I ask you what is the acid of carbonate or bicarbonate, you can write H2CO3. What is the acid from which sulfite is derived? H2SO3, and so. Medium stable acids, hydrochloric acid, HCl, hydrobromic acid, HBr, hydroiodic acid, HI, nitric acid, HNO3. High stable acids, phosphoric acid, H3PO4, sulfuric acid, H2SO4. Remember, as the boiling point of acid increase, stability increase. Stable acid means acid has higher boiling point. Okay. In this detection, generally the detection of anions, we should make slight heating. Yes, slight heating is preferred during the anion detection. Why? The answer is to eject gases. Why? I said before, the high stable acid replaces the less stable acid from its salt. The less stable acid is given out after the arrow and decomposed, giving what? Gases. From this gas, we can know, we can identify the anion. Yes, as we know. Let's move in.